Okay, we're asked to solve this linear differential equation. Before we start that work, let's just make sure what our goal is. In order to solve a linear first order differential equation, you have to start with it in this form right here. And you could also write it like this: y prime plus some function of x times y equals g of some function of x. Uh, where p of x and g of x have to be continuous. That's right here. Okay, so our goal is to transform this, if possible, into that form. So first thing I would do is divide every term by dx so that I could write this as y prime dy dx. So I'd leave this term on the left of the equal sign and transpose this term, which no longer contains the factor dx, to the right side of the equal sign, which means it'll change the sign. So I picture multiplying this bracket expression by -1. Then I distribute the e to the x, and now I notice if I move this term back over, I've got the form that I'm looking for, where this is p of x and this is g of x. Well, not quite. I've got to get y prime by itself. So if I divide every term by e to the x plus 1, this is the form I'm looking for. And this is where we can pick up the integrating factor. We want to find the mu of x is equal to e to the antiderivative of p of x. And that happens to be, by u substitution, the antiderivative of this is ln of e to the x plus 1, and e to the ln of anything is the anything. So there's your integrating factor. So if I multiply every term by e to the x plus 1, well, it turns out I'm right back to where I started. A little bit unusual. So in this form, after I've multiplied by the integrating factor, I can take the integral of both sides, where I've rewritten the left side using the product rule, e to the x plus 1 times y. The derivative of that is this by the product rule, and then the antiderivative is right back to where we started. And over here on the right-hand side, we can use u substitution, which I've done down here. I'll let you look that over, but you get e to the x plus 1 cubed. So that's where we are now. Divide every term by e to the x plus 1, and you've solved for y. So there's your solution right there. Okay, and if you want to see how to confirm that on Desmos, there's our solution, f of x, where c turns out, could be any real number, because this is defined everywhere. So if I rewrite this substituting f of x for y and f prime of x for dy dx, you can see I get a nice 0 here. So this indeed does equal 0 all the time. Okay, there you go. Hope that helped. If you have any questions, post a comment.